This is Astronomy Daily Live. Hey, everybody, what's up? What's up? How's everything going out there in the universe and the rest of the world? Hope everybody's doing well. All is well here. Let me be the first. Let me be the first, probably the first, to wish you a very happy solstice in at 10:08 UTC, which is only about 8 hours from now, the sun will have reached that point in time and space that we call at least in the northern hemisphere, we call it the summer solstice. In the southern hemisphere, of course, it's the winter solstice. So, yeah, that's the point where the sun is at its highest declination, the highest it's going to be um, above the horizon. Yeah. Um, yeah. So I thoroughly enjoy the solstices and um, equinoxes. I uh, I sort of treat them as holidays to a certain extent. Sometimes I treat them as an actual holiday and just you know relax at home and just be with the event. Sometimes that can't be done, and actually this time that can't be done. Other things call me away, so it's going to be a pretty normal day for me now. Technically speaking, since I'm 7 hours behind UTC right now, where I'm located, southeastern Arizona, United States, dark dark spot. Um, it is 7 hours behind UTC, so it is 7:02 p.m. Mountain Standard Time. Arizona is one of those few locations that do not observe daylight time, so it is always Mountain Standard Time in Arizona. So, and as I said, that's 7 hours behind UTC. So for me locally here, the solstice occurs at 3:08 in the morning. So I'm not going to be able to stare at the sun and wave, but you folks over in Europe and Africa, um, uh, yeah, some of Asia, I guess too, you will be able to wave to the solstice sun. So give it a good wave for me, because I've got this planet in the way, so it's pretty thick, so it tends to block the sun if it's on the other side. So what can be done? So cheers. Hydrogen hydroxide tonight, pretty much the go-to. Cheers. Oh, I need to freeze my or get out of my Linux or get out of my thing here before it freezes my machine, which it's already begun to do. I'm going to stop it. And I'm going to go to my. There we go. All right, cool. I made it in time. I'm going to go over to the chat, see what's going on over there. Come on. I think I see Uncle Bill. Uncle Bill is there. Bobby is there. Atta, Tom, Tim. Tim, you crazy man. Totterbert. Yeah, hey, we're getting quite a nice circle here, sharing the passion uh, for all things astronomical. Yeah, cool stuff. Hope everything is okay over there in the UK. I hope so. So yeah, solstice is a pretty special uh, occasion that I always try to mark in some way, in some small way. So I don't think I'm going to do anything in particular. So maybe I won't even mark it in a small way. But yeah, I know what's going on. I know what's going on. So that's good enough for me. So that's happening in a little less than 8 hours from now. Solstice. Solstice, summer solstice for the northern hemisphere, and winter solstice for the southern hemisphere. So yeah, very cool. All right, what shall it be? What shall it be? These are very casual conversations. We're not we can get pretty intense into things, and yeah, I think that's sort of the norm, to sort of dive into things and see what we can dig out, even if it's just you know pretty shallow. It might feel pretty complicated and deep, but I can assure you that most of the stuff that we go over is just sort of skimming, just sort of skimming. Um, Black hole mergers, not that I'm aware of. Not that I'm aware of. Yeah, that's up for debate still. We can think all kinds of things, how things actually are, but you know, the scientist in me uh, raises the skeptic flag, and it's a big red flag, right? That waves whenever there seems to be something funny about what's being said or what's being done. It's like, yeah, I don't know. So it's entirely possible, I suppose, um, that something like a black hole exists and that they can merge. Um, but yeah, I don't know yet. I don't know yet. I think we're making too uh, too far out of guesses, and yeah, I don't know. I don't I don't know if we'll ever actually know, because it's just uh, I think there for sure, right? For sure, there is something interesting going on, right? But what that actually is, I don't think anybody knows. I don't think anybody knows at all. You can make some pretty decent guesses, maybe. Um, but yeah, very skeptical of all of that. All of that. Wide open to it, though, right? I want to hear it, right? I want to be convinced, right? And if I can be convinced, then it's like, okay, let's let, let's start seeing if this applies. See, you know, uh, we make observations and then we theorize and then we make more observations. We do experiments, and I think we're getting close to a point where we can start doing some experiments like that. So yeah, cheers. Patrick Manny is in the house as well. Nice to see you. I guess in the chat, not necessarily in the house or out on the porch. Yeah, down on the porch. So yeah, hope everybody's doing well out there. Nothing incredibly exciting here. Nothing that I can report, you'll notice that I'm missing a telescope here, back here. Yeah, I've got it out in the hallway out there because it you know when things accumulate around objects like a telescope, um, it's pretty easy to remove things from that, but it's really hard to put it back where it was, because usually, piles of things grow, and so places that were available aren't available anymore. So yeah, in short, I've got to find some more floor space for this thing. Good. It's I think it's pretty unusual for the weather to be great over there for extended periods of time, more than a few days, more than a couple of days. So yeah, glad to hear that you've been doing the thing. Cool. Cool. So hope everybody enjoyed last night's live stream from the telescope. I'm not quite sure what's going on with this camera, but I think I noticed this last time I did it too, and I just forgotten about it. But when I have both cameras plugged in to this machine, um, for some reason Google Hangouts um, recognizes recognizes this camera, right? It identifies it, everything else. But when I try to start it, it says something like Google Hangouts, or this camera is incompatible with Google Hangouts, something like that. And I'm saying, no, it isn't. I mean, hello, do you see me here? This camera is compatible with Google Hangouts. Otherwise, this would not be happening. So, but for some reason, um, it decides to go into that mode instead, and so the use of this camera out there is non-existent. So it's all I can do is share my screen, which I mean I was going to do anyway, right? Um, and did the entire time. So I hope that wasn't. I mean that's pretty typical, right? What I was doing last night in terms of observing um, was pretty typical, right? I think the only thing that I would do differently is if I'm observing, if I'm um, doing it because I want to be doing that, not that I'm collecting science data, anything else. If I'm doing it just for fun, right, and not for any work at all, then I would definitely not use any of the go-to stuff. I would still want to do the alignment, so the telescope tracks reasonably well, but I would not use the go-to, right? I mean, if I wanted to find M13, I would slew it manually. Now, because I was trying to uh, sort of move as most efficiently as I possibly could. I didn't necessarily want to um, bumble around a little bit uh, doing that manually last night. So yeah, I sort of wanted to keep moving. So I did use the go-to last night very successfully. right? I mean, the that particular pointing model was actually pretty good. So, you know, when we did go to M13, um, I can be more than 50% sure that M13 was in that field of view. It's just too faint for this video camera and the size of this scope. Um, you know, larger scope, larger light bucket, the more photons you can gather. Therefore, the fainter you can see. Um, you know, if I had a larger telescope, I might be able to see that. Maybe, maybe, maybe. I don't know. I don't know. Probably what I could do, and maybe even should do, right, is record a little bit of that, and then I can just uh, stack the images, right, which is effectively taking a long exposure, um, and see if anything pops out. Now, because of tracking, it's not going to look very good, even if there is something there. But uh, I did not see anything on the screen, which was kind of a bummer, but not totally unexpected. So yeah, it was the seeing last night was some of the best I've ever seen here. I mean, I've seen a lot of good seeing nights, and it was a good seeing night. So yeah, that was pretty nice. Um, I haven't looked at Venus in a very long time. So that was for me a little extra bonus, especially because you can see that it's a um, it's going to be a waxing gibbous waxing gibbous moon right now. So um, uh, live stream is great. Yeah. So my monkey puppet routine I was going to use on my live streams. Uh, this is Gordon the Gopher. You go ahead, maybe. Maybe a collaboration. Yeah, yeah. You can do anything with green screen. So yeah, it was. I think that was a little bit fun. Um, uh, got some um, got some really interesting views of the moon, different mountain ranges that were really popping. So that was very cool. Um, and Jupiter, of course, because it's there and it's awesome. And I guess we did see all four moons. I posted a simulated um, uh, view, um, and it looks and I'm see what I remember is that two moons were here, right, so, sort of spaced far apart, and then there was one moon up here and then one moon way out here. Wasn't it way out here, or was it down here? I'm gonna have to watch the video to find out exactly. But yeah, I guess that configuration was right, but I'm gonna have to confirm it because I thought that there were two on one side and two on the other side, and what that plot is showing is three on one side and one on the other. So I think Europa that was on the one side, and then Io and Ganymede and Callisto on the other side. And I just remember two and two, um, as opposed to one and three. Um, yeah, Ata, I actually saw uh, your comment last night that said pretty much exactly the same thing, and I totally agree. Um, And as I said, I mean, you know, when we're looking at things, we're I mean, uh, in a certain sense, we are making a physical connection, right? I mean, call it the electromagnetic field, right? Because that's exactly what it is. The that object's electromagnetic field is interacting with 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 your eyes, and so you can see it. Yeah. So you know, there's some, you know, I mean, one might say it's like a different kind of touching, right? I mean, it's touching, but it's just a different kind. And so, you know, we're in, you know, physical contact with these objects, um, uh, just based on, you know, being uh, wiggled by their electromagnetic fields. Cheers. Uncle Bill's the man. He is a ninja dude. He is taking care of multiple science channels at the same time right now as we speak. Probably at least 50, at least. I mean, that's on a slow day when he's a little tired and needs a nap. Yeah, yeah. Tim, I like seeing all the telescope live streams because they're all so much better than mine. So I like to see all of those because it's like, oh, okay, that's what it really should look like. see, see, Uncle Bill, I think I woke you up. Sorry. Knock, knock, knock. Yeah, very, very cool. So yeah, that was really, really fun, and I will do it again, and that that will also evolve and grow, and always try to get better and better and better. I don't always succeed at getting better and better and better, but I am definitely always trying to get better. So yeah, cheers. All right. Well, I've been posting some things uh, over on the Discord server. Um, we could go that way. We could uh, we could um, we could look at the sun. You know, I think that it would be I think that it would be very, very appropriate for us today, on the day of the solstice, to look at the sun. What do you say? That just dawned on me. It's like, yeah, I think we need to look at the sun on the solstice. Yeah, yeah. Well, the the popular channels um, very, very much do need moderators, because otherwise a lot of them would just be completely uh, overtaken and overrun by you know, people who want a special kind of attention. So yeah, so I'm going to load up my Discord here. Oh no, no, we're going to go over to the sun. That's right. Okay, we're going to go over to the sun. I'm going to share my screen. So bye bye, bye bye. Hide that, and we're going to go. Let's see. there are three sun sites, sun websites that um, uh, that I like to go to look at the sun. And yeah, I uh, I've heard them being called trolls, and I think that just does them a favor. So yeah, yeah. So I'm sort of wondering which one we should go to. There's Soho, there's SDO, and there's Iris. Um, I guess probably what we should do is um, SDO is sort of the um, uh, SDO is well, there's really no comparison between SDO and Iris, but between Soho and SDO, I prefer SDO. It's a little, I think it's a little higher resolution. So the Solar Dynamics Observatory. Let's look at the sun. It is not SDO. No, not the SDO. So that's what the sun looks like as of 2:10 UTC. So 17 minutes ago. 17 minutes ago. Let's go to data here and go to the sun now. We can really we can take a good hard look at the sun. So these are, of course, the same sun, imaged at different wavelengths of light. So essentially, what what you're doing is you're seeing different materials, different things in the atmosphere slash on the surface of the the sun, um, and looking at different wavelengths presents different materials in different locations. So the numbers there 193, 304, 171, 211. That's the wavelength in angstroms. And so, they go, there are quite a few here, right? 193, 304, 171. Patrick. All right. So I'm being distracted by the chat, which is actually a nice feeling. um, so 171, 211 angstroms. Come on. 131 angstroms, 335, 94. So this is very ultraviolet. 1600 angstroms. So that's still ultraviolet, but it's getting more towards the visible. Here's 1700 angstroms, and then they've got a series of these where they combine three of them. Um, so these colors, right? These colors that is not the color of that wavelength. What they've done is they've all the solar observers, all the solar astronomers have agreed to a coloring scheme for certain wavelengths. So, and what that does is it allows you to immediately know what wavelength of light you're seeing the sun in, right? Instead of having to be like, okay, what's that? you know, what wavelength is that? As long as you remember, that the yellow one is 171 and the purple one is 211 and the red one is 304 and the peach colored orangish one is 193 and so forth, right? Then you can just look at these things and know um, and know uh, what's going on with them. So then, they combine a few, which is cool. This is a magnetogram. It's showing the magnetic field um, strength. You can see that there's a bunch of sunspots. Um, this is pretty much visible wavelength, and they've just flattened the sun here. Do you see how it darkens on the limbs? That's actually called limb darkening. And the most popular explanation for that is that here you're looking through a certain amount of material, but the sun is a sphere, right? So as you move away from the center, right, as you move away from the center, you're actually looking through more material. So as you move out, you're looking through more and more and more stuff. And what that does is exactly what it does here on Earth. It reddens things. Um, it darkens things. It reddens things, and that's just an atmospheric effect. In this case, the atmosphere of the sun, right? The atmosphere of the sun is causing that. And in this diagram, this is exactly the same thing. They've just taken um, that curvature out. So let's take a look at, so this is pretty much a visible light image flattened. Take care, Tim, if you're still there. Nice to see you in the chat. Appreciate you coming in, Tim, anytime. So there's some pretty cool looking little sunspots, little ones, but good resolution. And there's another set. This white stuff here is called plague. Is it called plague or is it called plaque? I think it's plague. And there's a little bit more plague up here. Kind of cool, huh? Sort of like well, I wouldn't call it pre-spotting. Now, do you see all this granulation, all this how bumpy it is? That's the real deal, right? The the conventional thinking is that these are convection zones, and they're big, right? They're really big. Thousands of kilometers across at least. Um, and it's convection. It's the as I said, the standard conventional theory is that these are convection cells, the tops of convection cells, and this is one of the ways that the sun transports its energy out of the center is through convection. So yeah, all this is quite real, quite real. Interesting little structure here around that spot. So this dark area is called the umbra, and the area around it is called the penumbra. It sort of looks like um, uh, like a freckle. So that's pretty cool. So that's what it looks like. These things look like essentially in visible light, right? I mean, if you were able to look at the sun through a telescope with some kind of a filter, yeah, this is basically what you would see, right? Um, But let's look in like the far ultraviolet, right? That's this one, 94 angstroms. Let's let's get let's choose the biggest one, the highest resolution one that we can get, 4096 on a side, taking a million years to load. Bye, Tim. So there we go. Now this speckle is probably noise on the camera. It's probably noise. It's probably not exactly associated with the sun. Now I could be wrong about that, but the fact that it sort of is speckly where there is no sun and speckly where there is sun, yeah, that tells me that it's mostly noise. You can see these big or these big black areas. Those are actually holes in the corona of the sun. And typically there's one on the north and one on the south. And then you'll have these other ones that come and go, come and go. So it's almost like, the corona here is like the atmosphere, right? But it has all these holes in it. And these holes are where, uh, more dense material can escape, can get out. So usually, if you have a coronal hole, you know, sort of in the equatorial region here, like if this one comes around, um, we, that's like a fire hose, right? There are these high energy particles. They're just going to be shooting out of that hole as it rotates, right? So we're gonna we'll receive a spray of that stuff, and that causes the northern lights, and general havoc with radio communication, some electronics. Um, Sort of depends on the strength of that. So these coronal holes can well, you know, they probably both help and hinder um, radio communications, right? Because they just dump a whole bunch of usually positively charged material. Um, they dump it into our magnetic field, and then that material gets sort of directed down onto our poles, and dispersed, of course, through the ionosphere and elsewhere, I suppose. Um, so yeah, they're pretty amazing things. Um, you can also have what are called coronal mass ejections, CMEs, and that's when one of these areas, right, these so-called active regions, which is where the sunspots are, sometimes you will get what is commonly called a flare, and nobody really knows what is going on with flares. There's a bunch of ideas. Um, I think and I definitely don't know the uh, the uh, um, the exact current storyline. But it probably has something to do with magnetic recombination, and yeah, I'm not quite sure. Not quite sure, but they can be energetic enough to actually cause like a pretty massive explosion and just spew uh, some some of the contents of the sun out into space. And if those flares go off when they're basically equatorial and facing Earth, then it's obviously extremely likely that we're going to get bombarded by those, and we do all the time. We do all the time. Happens pretty often. Pretty often. Let's get a this is a pretty grainy image. These are kind of interesting. See how you like these. So this is at 1600 angstroms. So that's the same sunspot group as we were looking at before. Remember the plague region over here, and then if we scooted over, we saw another sunspot area. There it is. It's like a couple of owl's eyes, and then there's another region back over here. So yeah, we're just, you can see that the granulation has changed a little bit. It's changed. See how there's even, you know, so-called limb darkening observed here because you're just seeing more stuff. That's sort of the explanation. I don't know if it's the right one, but it's an explanation. Where's that one? Oh, this one. Yeah, this is the one I meant to show you before. Arr, he's getting a pirate. So there we go again. This is showing the actual magnetic field strengths. What do they call these? A colorized magnetogram. Haha. So this is showing not only the polarization, but the strength and everything else. I think red is positive and blue is negative, and then green is somewhere in between. So it's apparently when these positive and negatives mix that you get these flare events. But isn't that I I think these are absolutely gorgeous. That plague region. You see how they can just be split, right? Over here is positive and over here is negative, right? And there's this very sharp defined line, right? And that's usually how these things go. They usually appear in pairs, and they're usually one is positive and one is negative. And I think the positive ones tend to lead, if you sort of think that the sun is rotating this way towards the right, then the positive ones seem to always lead the negative ones. Let's see if that's true over here. Yeah, see, positive over here, negative over here. This one you might be making me a liar, right? But ooh, there's some interesting mixing going on here. I'm wondering if that's popping or not. Now, what I like to do is I like to look at these movies. Let's see, is this gonna, how is this gonna, okay, it's gonna do that. Uh, let's see, let's just do it like that. 46 seconds left, so we can look at a couple of these other ones. I think out of all of them, I really like this one the best. Just in terms of um, just how it looks. So again, this is just a different wavelength of light. It's the same sun, right? This is the same region that we looked at just a little while ago. Now we're looking at different materials, probably in different locations. So these are described as material sort of moving along these magnetic field lines, um, and that's what all this is. So there's that other region, and here's the region on the side, and you can also start seeing um, Wow, look at this loop here. Holy moly. That's awesome. Wow. Yeah, it's hard to see far away, but look at that. There's an inner loop here too. Look at this. And then there's this one. Wow. That's incredible. That is really incredible. And then these things actually extend out into space. They actually just keep going, right? Some of them loop back, but others just keep going. You can see some, um, what are those called? Um, these these guys. Um, you see them often. These are coronal holes. Where do you see those? I'm trying to remember which wavelength of light pops those out the most. I don't know. Forget what they're called too, which is a real bummer. Looks like this movie is ready. Yeah, here's some nice prominences over here. Actual, material jumping off the sun, being held up held up by, I guess, magnetic fields, something like that. Very spiky. Look at that. As far as I'm concerned, this is the way to observe the sun. Although looking at the sun through a telescope does have exactly the same effect as looking at anything else in the sky. So it's like, there's a connection there. Okay, let's try to run this. I think it's trying. Is it trying? Up there it goes. Oh, I've got it on zoom here. Let's get it out of zoom mode. I don't know how it got it. Which one is that? Here we go. So there's 48 hours worth of rotation. So that's pretty cool. Now let's zoom in a little bit. So you can watch these things evolve, grow, and change. Let me try to get in here. Oh, why does it do that? It's just it's being mean, being really mean, not letting me do what I want. I didn't know that it reset itself after every loop. That's kind of stupid. Yeah, it's pretty lame. And I like VLC, but it's disappointing me here. Anyway, you can sort of see how these things are evolving, right? They just popped up out of nowhere. Watch that. They just pop up out of nowhere. That cool or what? I wish I could show you the rest of the sun, but under Zoom, we can't do it. Look at that. It's going to go right back. Yeah, turkey. Well, I don't like that. I definitely don't like that. Oh, well. Thing. So that's pretty cool. Looking at the sun. Whoop. Got rid of Chrome. Hope I have to restart Chrome. Let me stop sharing. Stop sharing. And then I've got to restart Chrome. I accidentally deleted my Chrome window. But there it's back. And we got to go back to SDO. So as far as I know, all of this data is available, you know, in a scientific form, probably fits files. So yeah, we should probably play with this actual data, because what I'm showing you here are sort of data products, right? Let's look at the 211 is the best one to see the coronal holes. So for some reason, this is doing it like this. So some pretty good coronal hole up at the north and probably pretty decent at the south. You got this here that's coming pretty far down, pretty far down. And it looks like another coronal little one. But you can see how incredibly dynamic the sun is. Just amazing. See the date and time down here? And, you know, kind of a thin corona through here that seems to, you know, get thinner and thinner as it rotates around. So that's 48 hours of rotation also, right? So that's 2 days. Now, the one thing that SDO does not have is it does not have a wide field view, right? I mean, it's got this. But Soho has these two cameras that offer a little wider field of view. So let's go to Data Archive, and we'll do the sun now, just like before. And so as you can see, here's all the colors again, right? And they're all the same as the other one. But as you can see, this is showing these LASCO C3 and C2 camera views. This is the widest field of view. And so this little white circle here, we can zoom in a little bit here. This little white circle here is supposed to represent the size of the sun, right? Then they have this thing to block the sunlight, and here's the little thing that's actually holding it, right? This is probably a software block. It's probably pretty ugly and messy in there due to diffraction around the edge of the coronagraph. So yeah, it's an actual physical object that they put in front of the sun to block the light from the sun, so everything else pops out, including background stars. Most of these, what you're seeing, are stars. Some of them are, cosmic rays and other energetic particles, but we can actually watch the movie on this one. Let's see. Okay, so this will probably be a little bit interesting. If it decides to load. MP4. I don't know if that's loading or not. Let's try to save it. Yeah, a couple minutes on that. So that's the wide field one, right? And then there's a narrow field. Well, I'm not going to do the movie. And then there's a narrow field one too. And I think that the narrow field one is essentially this flat blue area. That's where this whole field of view is. Let's take a look at that one too. So just a narrower field of view, but yeah, all this is real. All this is shit streaming off the sun, right? Following these so-called magnetic field lines that are just stretching out into the heliosphere. Again, you can see a lot of the stars. There's a lot of stars. There's, some cosmic rays, energetic particles, but, a lot of these are stars. I don't see any comets. Sometimes you can see comets. They've actually discovered, I think, over 3,000 comets just by watching these. It's almost done, 26 seconds. So, more or less the same view as SDO. I mean, we are looking at the same sun here. Interesting dark structure right there. All right, that finished. Let's run it. So on the left side is showing the actual picture, right? And on the right side, what you're seeing is the difference between adjacent images. So it's like they took image 2 and image 1 and subtracted. And so you're looking at differences. Ooh, look at that thing blowing out there. Wow, that's a beautiful spiral. Did you see that? That was a great spiral. Let's watch that again. But you can see, you know, this gives us a chance to see how things are changing. And look at all that shit flying out over here. Here it comes. Boom, look at that. Wow. That's great. That is very, very great. So very cool. So that's the wide field one. And as you can see the stars back here are moving, right? They're moving that away, which means the sun, of course, is moving to the left. Wow, that's great. It looks like a smoke ring. Looks like a smoke ring. Very cool. Let's look at the other one, the narrower field of view one. MPEG movies. Atta, there is. We don't even know how much we don't know. Oh, save link as. Okay, that'll take a couple minutes. Couple of minutes. $47 seconds. Oh, I saw 50 seconds there a little while ago. Taking its time. Cheers. $25 seconds. Going up, going down. My internet's a little bit slow tonight, it looks like. So yeah, looking at the sun near the solstice, right? We are now a mere 7 hours from the solstice. 7 more hours. Yeah, you know, Atta, I think that's one of the things that I thoroughly enjoy is being able to share um, um, websites that I have found because you know, I mean, as a scientist, I'm looking for data, right? And so I I I look almost continuously for more and more and more, and a lot of these, you know, I sort of stumbled upon. Um, but yeah, it's absolutely cool, right? To be able to come up here, right? And okay, look, it is 3:03 UTC, right? This image, this image here was taken at 1:19. So just a couple hours ago, right? Just a couple hours ago, this is what the sun looked like at that wavelength. So I think that's very cool that we have access like that. That just blows my mind, right? All right, let's run this one. So this is the narrower field one. This is LASCO C2. Same kind of thing, right? You're seeing the differences. And where it's flat, of course, there's no difference, right? So that's inside here. But you're seeing all this material blowing off, and we're going to see that big one up close now. We're not going to see much of it, but look at all that stuff that is coming off already. Boom, look at that. Wow. Yeah, that's great. And notice how much it changes, right? I mean, how things change, how the positions of these beams change. All that stuff flying off of there. Here it comes. We're going to do it again. Boom. Wow. Yeah, that's fantastic. I want to watch the other one. I've been watching the difference frame one. I want to watch this one over here. Okay, very cool. So yeah, it looks like they're missing some frames right at the actual event, which is actually pretty. It happens more often than not. So I'm sort of thinking, now that I'm seeing this a lot, I think that's an optical effect of some sort. I don't think that has anything to do with the sun itself. Um, looks to be some kind of optical effect. But wow, yeah, that's pretty awesome. Very, very cool. Well, Atta, that's why a lot of people in astronomy have actually been working for quite a long time on how to handle massive amounts of data, and not only how to sort of catalog it and store it and describe it, but then how do you find something in it, right? And so everybody's moving towards machine learning and those kinds of things, and so yeah, it's a good kind of problem to have, but it's a big problem, and it's only going to get worse. It's only going to get worse. Um, yeah, Uncle Bill, I totally agree. It's like, to get these kinds of images on my own, well, for me, it's impossible. I can't. I don't have the equipment. Um, so, yeah, it's very, very awesome. It's also cool, that these are satellites in space, so there's no atmosphere to contend with. So that makes it really, really nice too. You're getting as high resolution as you can get with the instrumentation they have. So yeah, yeah, totally, totally agree. But yeah, the amount of data, Atta, is in its infancy. Okay, you haven't seen nothing yet, nothing. It's gonna turn into a bigger and bigger and bigger problem. Um, yeah. All right. Well, looking at the sun on the solstice, I think is very appropriate, and I think therefore for the for the solstice this year, looking at the sun, I think was a great idea. All hail the sun. Without the sun, so the story goes, we wouldn't be here. Nothing uh, really would. So yeah, that's debatable. Who knows? Um, we don't know what conditions um, are necessary for existence. So yeah, hard to know, but at least what we think we understand about our kind of existence um, requires that big bright star up there, and yeah, I think the sun is extremely awesome. Uh, total respect, total respect for the sun. That sun runs the show. It really, really does. So it's an amazing object. Um, we really don't have a clear understanding of what it is and how it works. Despite what you hear, despite all the surety out there, the fact of the matter is that we really uh, have some decent guesses, um, but what's actually going on, I don't think that we can imagine that yet. Yeah, I think it's amazing though. I think it's totally amazing. Whatever it's doing it very well. So keep it up, Mr. Sun. We greatly appreciate you out there. It's I especially do. I thoroughly enjoy being completely engulfed by your electromagnetic field as often as I possibly can. So, and the more intense that field is, the better I feel. So, thank you, sun. Happy, happy solstice to everyone, be it the summer solstice or the winter solstice, whichever side of the planet you're on, top or the bottom, or bottom and top, however you want to put that. Um, all right, well, I am going to get out of here for now. So take care, everybody. I will see you again tomorrow on the spin. Okay, the Earth is going to spin around one more time, and it's spinning. So I'm not quite done yet. Hold on one sec. All right, yes, I have definitely been summoned away. So I'm going to get out of here for now. So take care, everybody. Have a great evening, a great day tomorrow. And I will see you, as I said, on the spin, 2 hours UTC. All right, happy solstice. Bye.